In this video, we're going to build an expense tracker using Neon, a serverless Postgres database, and Prisma as our ORM, and NextJs 15 with the latest features. So we're going to end up with something like this that you can add an expense item, let's say an amount, and then add it's using server actions and new features in NextJs 15, which we're going to walk through. So let's dive right in. Neon is kindly sponsoring this video, so thank you to the Neon team for supporting the channel. Now, Neon is serverless Postgres. You click a button and you get a connection string or a URL, a serverless endpoint up in the cloud that scales up and down based on your application workload. This is possible because they have separated storage from the compute. So the compute or the serverless compute runs separately from the storage layer in Neon. Now it supports traditional TCP connections using any Postgres driver, but you can also use the Neon serverless driver, which is a Postgres driver for JavaScript or TypeScript that allows you to query your database over HTTP or WebSockets, which is suitable for environments like serverless functions or the edge environment. Now, a cool feature about Neon is branching. So it allows you to work with your data the same way that you work with your code. Just as you can create branches from your main data, you can create branches from your data in Neon. Now, a branch includes the schema and also your data in an isolated copy, so you can work in development, testing, preview deployments with real data and schema instead of having to seed your database or development database with mock data. Each branch has its own URL and again scales up and down automatically. Now, if you haven't already, you can go ahead and create an account, log in with any of these social providers, and this is going to take you to an onboarding flow to create a project and then a database by default, which is called NeonDB. So in my dashboard, I'm going to create a new project. I'm going to call this demo, and the version of Postgres that you want to use, the region that you want this database to be deployed, and you can hit create a project. This is going to automatically create the NeonDB database for you and a main branch, which you can use to create isolated copies later on for your development or for your preview deployment. And down here, it walks you through different drivers and environments that you could use to connect to your new database. If you scroll up to the dashboard, you can also see your connection string here. So let me just make this a bit bigger if this is a bit small. So inside of our new project, we have our Neon database. We are currently on the main branch, the role and the compute or the access level that we have defined here. You can see we have this connection string. Now, something that Neon also supports is pooled connection. Oftentimes when you are accessing your database from serverless environments, as your workload goes higher, so does the connections to your database. So instead of exhausting your connections, you can use a pooled connection string, which is going to append your connection string with this pooler, which is very suitable for Next.js applications since they use serverless functions and edge functions. Now we're going to walk through connecting to our database using Prisma, as I mentioned, as our ORM and the setup. But anytime that you wanted to go back to the quick start to see the options here or to get started, it is here in this menu. You can also go to the docs where I can show you from a high level. There's this getting started, playing with Neon and connecting to your database, some references and concepts in Neon. There's framework-specific quick starts such as NextJs and also Prisma. There's going to be links in the description for your reference to find the correct pages in the documentation, so definitely check them out. Now, I've created a little walkthrough for us to create this expense tracker application together, and I'm going to follow this, but it is basically my notes from the documentation just synthesized in this Notion documentation page so we can follow along together. Now, the first step is to create a Next.js app. I have used my own Next.js template. So if you go to my repository, again, link in the description, there is this Next.js, which is a public repository. You can use it to clone it to create a Next.js app that works with TypeScript, Tailwind CSS, and Chat.cn, or just start off from a brand new deployment. This is what I have done. Again, link in the description for you. Now, for the features that we are using in this expense tracker, I want to upgrade to NextJs 15, Now, there's a video on the channel where we talk about Next.js 15 and the RC and the upgrade guide, the new features. There's a link in the description or somewhere in the card. You can watch that video if you're interested. You can also head to this upgrade guide in the documentation where it walks you through the necessary steps to upgrade your Next.js application to the version 15 or to the RC. Just a quick note that if you go to the regular documentation, you won't see this upgrade guide for version 15. It is only available at this rc.nextjs.org. Again, link is in the description, so go ahead and use that link. So I'm going to copy this pm code that is basically updating my packages Next, React, and React DOM, and also ESLint to the RC version, which is the latest version of Next.js that supports all the new features in React 19. So let me copy this. I'm going to come back to my code, open up my DevTools or terminal. Let's copy this command. So that's the first step. We got our application upgraded. I can close this and let me also close this up. So the first step was to create our Next.js application. The next step is installing Prisma. Now, Prisma is a type-safe ORM. If you're not familiar with Prisma, there's going to be a video on the channel linked in the description or in the card somewhere. It basically allows you to connect and query your database using a standard API, which is through the Prisma client. So we're going to go ahead and install that. So I can run pm add Prisma. So let's go ahead and copy this code. Once you've done this, you want to initialize a Prisma by running npx or pm/dlx, depending on the package manager you're using, and then the Prisma, and then the init command. What this is going to do is that it is going to create a prisma.schema file inside of your repository. So down here, I have this schema.prisma. I'm going to explain what's happening here. So we're using a Postgres database, and then we have to have our database URL. This is our connection string, which we're going to copy from our Neon dashboard for Prisma now to be able to connect to our Postgres instance. So it also has automatically created this .env file in my repository. Now, this is not by default added to your git ignore. So you can go to your git ignore and add this .env file so you're not accidentally pushing this or committing this connection string to your repository. So I added this up there. Now let's go back to our Neon dashboard. And then from here, I'm going to click this pooled connection and copy this connection string, bring it to my env file and copy this over here. Now, something that you need to also pay attention to is that this SSL mode equal to require at the end of your connection. This makes sure that the connection is only over safe or SSL connections. Now, as I mentioned in the beginning, Neon also supports a serverless driver that allows you to query your database over HTTP and WebSockets, which is suitable for serverless and edge environments. So we're going to set up Prisma to use this Neon serverless driver instead of the default driver that Prisma already ships with. Now, to do this, you need to enable this driver adapter. So we're going to use an adapter from Prisma to then pass in this Neon serverless driver and replace it with the default driver in Prisma. So inside of our schema.prisma, we have to add this preview feature, which is in the newer versions of Prisma, to then enable us to use an adapter to use a different driver instead of the default driver from Prisma. Now, you can still use Prisma driver if you want to. If you are using serverless functions, the Prisma driver would be fine. But if you want to use or query your data over HTTP from the edge runtimes, which doesn't support TCP connections or traditional connections to databases, the Neon serverless driver is the driver of choice. And so therefore, you need to use an adapter to tell Prisma to use that driver instead of the default driver. So let's go ahead and install the adapter, the Neon database serverless driver, and also WebSocket package. So let me just copy this code and come back to my terminal and add these packages. You can also go ahead and install the necessary types for the WebSocket package as a development dependency. So just to double check that this is installed now, let's go to our package.json. Make this a bit smaller. So we have the serverless driver, we have the Prisma adapter, and we installed the WebSocket connection. Now in the next step, let's also install Prisma client. This may not be necessary if you run the generate command. It automatically installs this. But while we are here, let's also go ahead and add Prisma client. Now, anytime that you're working with Prisma, you're going to create a Prisma client that's tailored to your specific database schema, which makes it easy to run type-safe queries and access your different tables and different functions that's accessible through the Prisma client. So to instantiate a Prisma client before we actually create our schemas, I'm going to copy some code here and explain what we are doing here. So inside of my lib, I'm going to create prisma.ts file. Inside of it, let me copy some code and explain what I'm doing here. So there's two different things happening here, which I'm going to try to explain. If we go to Prisma documentation for a second, let's go to the docs, resources, and docs. If you search for the best way to instantiate a client in NextJS, you're going to see a solution here. Let me just make this bigger. Now, instead of returning this new Prisma client that we're creating here directly from this file, we're going to hold a reference to this Prisma client in our global this object to avoid recreating this Prisma client in local development. Because of the hot module reload in Next.js in dev mode, when you are working on your application in your local machine, to avoid recreating the Prisma client and exhausting your connection pool, we're going to save this Prisma client in our global this using this singleton pattern. So we have this function that returns a Prisma client. We're going to call this function if it doesn't already exist inside of our global this object. So this is the first pattern that we're going to use based on Prisma documentation to create a Prisma client in Next.js. Now, the second thing that I've combined or we're combined with this step is actually telling Prisma to use Neon's serverless driver instead of its own default driver. And this is what's happening here. So we are setting some config to this WebSockets. We are retrieving our connection string from our local environment variables. We are creating a pool using that connection string. We are then using this Prisma Neon adapter to then create our Prisma client. And then we're going to share this Prisma client with this new adapter using the Neon serverless driver and share that throughout our application. So it's the combination of this step. And if you walk through Neon's documentation for using Prisma, you're going to see this second part that I mentioned down here, where they actually talk about changing the default adapter or the default driver for Prisma to use this Neon serverless driver. Now that we are here, also let me mention that you need to also install this buffer util package. Sometimes you might run into errors, as I did. So let me also add this pm add -d as a development dependency. Let's clear this up. Okay, so let's go back to the next step. We've installed the buffer util, and the next step is for us to create the database schema. So let me close this off and recap what we have done so far. So first step, we created our Next.js application. We upgraded it to Next.js 15. Then we installed the Prisma package and ran the Prisma init command. This in turn created this schema.prisma, where you would include the type of database that you're using and the environment variable that is holding the URL or connection string to your database. It was also creating this .env file for us, where we copied our pooled connection string from our Neon dashboard to this file. We also added the .env to gitignore because it doesn't have it by default in Next.js. It only has the .local because the convention in Next.js is to use the .env.local in your local development environment, but you can also use the .env. This is how Prisma works, but make sure to add it to your .ignore. And then inside of our schema.prisma, we told Prisma that we want to use an adapter. So we're going to install the adapter and we're going to use the Neon serverless driver instead of the Prisma driver so that we can query our database from our serverless environments and edge runtime using this over HTTP instead of the traditional TCP connection. So to instantiate a Prisma client, inside of our lib folder, we created this prisma.ts using Neon serverless driver and hold a reference to this Prisma client inside of our global disk object so that we're not recreating this Prisma client on every hot module reload in our local development environment to prevent exhausting our connection pool. Now, the next step for us is to actually create our database schema. Now, we're going to create an expense tracker. So let me just copy the model that I've created here. So I've created an expense model. This is going to map to an expense table inside of our database. There's an ID. This is the unique identifier for each record inside of our table. It's defaulting to UUID. It created that field defaulting to now, updated that title as a string, and an amount, which is an integer inside of our database. So I kept it simple here, but you can extend this beyond just one table. And this should be enough to just get the concepts down. Once we created this model or this schema inside of our Prisma, we want to now sync this with our database schema. And for this, we're going to run the Prisma migrate command. So you can run it with npx Prisma migrate, or in my case, pnpm dlx Prisma migrate dev, to then map this to our new database that we created. So let's go ahead and copy this code. Now this, as I mentioned, is going to create a new SQL migration based on this schema we just created inside of our Prisma. It's going to then run that migration against the database to match or sync the database schema to this Prisma schema. And then it runs the generate command to create or generate the specific Prisma client that's built using this schema we just created. Now, as you can see here, it tells you the migrations that was created and also that it has generated the Prisma client. Now, if I go back to my Neon dashboard for a quick second, if I go to the tables, we should be able to see an expense table and the Prisma migration that was run. So there is an expense table here. There's no records inside of it, but this shows us that this migration was completed successfully. Now, something you can do to also have a look at your database tables is to use the Prisma Studio. So you can run npx Prisma Studio or pnpm dlx Prisma Studio. This is going to run on localhost 5555. It actually opened automatically. This looks at your schema.prisma and based on that generates this GUI for you to interact with your database. So for example, you can add a record here, you can give it a title, let's say fruits, and then let's also give it some amount. This in turn is going to create that record inside of our table for us. Now, just to see this also reflected inside of our dashboard in Neon, if I now refresh the page, I can see this new record now for the fruits and the amount of 50 also inserted in my Neon database. Now, as the next step, we want to fetch these expenses inside of our home page, just like the app that I showed in the beginning. So inside of our page component, the idea for me is to go ahead and fetch my database or fetch the expenses from the database right here inside of my server component. So I can render them down here. So let's fetch expenses. Now, to do this, we're going to create some functions that talks to our database. So let's go inside of our lib. Here, I'm going to create a file called expenses.ts, where I'm going to export some functions that allows me to talk to my database. So let me explain what I've created here. So I'm using the Prisma client that we created inside of our lib Prisma. This is the Prisma client that we created. Now I'm going to use that client that I created. And I'm exporting some functions, get expenses, create expenses, which is going to use Prisma client under the hood to then query my database, such as this one. It's going to access the expense table and then find all the records there, or create an expense which expects some data, which is amount and title. And then it uses Prisma client again on the expense table to create a new record with this data. So simple functions that now we can use inside of our page component. So here I can say const expenses equal to await get expenses from our lib. Now I need to turn this into an async function to be able to get that expenses. Now that I have my expenses, I'm going to come down here and actually map over them and render some list elements for each expense. So let's run our dev server inside of another terminal window here, pnpm dev. Here we go. So we have our only item that we created inside of our expenses here and the amount. Now, the idea is for us to also add a form so we can use server actions in this case and our Prisma client to then insert a new expense inside of our database. So let's go ahead and create this component over here. So inside of components, I'm going to create a new expense form.tsx. Let me copy some code and explain what I'm doing here. So from a high level, this is just rendering a form. And inside of this form, I have two inputs for a title and an amount. And then I'm using server actions to handle form submission here. To use actions, I'm using this new use action state from React 19. This was used to call use form state in prior versions of NextJS, prior to NextJS 15, if you have used it already, and it was being exported from React DOM. But now the new use action state is exported from React, and it's basically the same hook with some updated features. Now you have to pass in a server action to this. We're going to create this server action together in a second, some initial state, and this hook is going to give you back two values. The current state of the form, which is going to be the initial state before the form submission, or once you have submitted the form is going to be the result or return value of your server action. If there is any result, a success message or error message, this is what your server action is going to return. And then it's going to also give you a form action, which you can pass to the action prop of your form. Now, if you're not comfortable with this, I have a video on the channel where we talk about use form state and use form status. The use form state is basically doing the same thing, so you can watch that video. The only difference that I have seen between the use action state and use form state is that when using the use action state, it automatically resets the form after the form submission, whereas the use form state wasn't doing it, and you had to pass in a specific ID to this for React to re-render your form, but this is taken care of in the new use action state. Now let's go ahead and create our server actions. Now the convention that I like to use is to create an actions file inside of my library. So I'm going to go actions.ts. Let me copy some code here. So inside of this server action, which I called create expense action, to differentiate it from the create expense function that's using Prisma, which is our database access function or object. Now this is going to receive this state. This is the same state that we have inside of our form action or use action state. And also it receives the form data. So once the user goes ahead and submits this form, these two data are passed to our server action. Now to create server actions in a separate file, you can pass this use server directive up top, and you can export as many functions or server actions as you want from this file. This is going to tell Next.js that to treat them as server actions. If you were to create this inside of a server component, you could have just passed in this use server on the first line here. But I like the convention of having all of my server actions in one file or even in multiple files, but using this use server directive up top. Now, the first thing that we're doing is to mapping over our form data and turning them into an object. Just basic validation here that we do have a title and an amount. And once we make sure we do have that, we're going to call this create expense function. This is our database access object or function that uses Prisma to actually insert a new data in our table. So from here, we are calling that, passing the title and amount. And once this is successful, we're going to revalidate this path, which is going to purge the cache and refetch our database to get the newly created expense item. Now, as far as error handling and returning errors here or validating our data better than this, watch that video that I have about use form state and use form status. It's called error handling. I'm going to link it in the description or somewhere in the card, where I dive deeper into a proper error handling inside your server actions using these two hooks. Here, we're doing a very simple error handling. We're not returning any error messages, but I assume that you already know that, or you're going to watch the video that I mentioned if you want to learn more about that. Now that we have this server action and the new form, let's just go ahead and bring this form inside of our homepage. So I'm going to bring in the new expense form. Let's save this up. Okay, great. Let's actually turn this to item start. So they're going to align on the top. So we have our items here and we have the add new form there. So let's add something here like rent 1500 and add. Now this is going to add this item through our server action, it's going to then revalidate the path, which purges the cache and refetches our database. So we could see the newly created expense item. And if you noticed, it also resetted the form. This is the difference that I have noticed between the use action state and the use form state. So let's create another one. Let's say we want to buy a course. By the way, if you're interested in learning Next.js and the new features, I have a course. There's a link in the descriptions. You can check it out. As a thank you for hitting 100,000 subscribers, there's a huge sale going on the course, so definitely check it out. So let's say 50, and then this adds it to our expense items and refreshes this form. Now let's go back to our Neon dashboard and check to see if our expense table also reflects this newly created data over here. You can again use this table editor or the Prisma Studio and refresh this to see or interact with your database. Now, before we wrap, I also want to show branches in Neon. So inside of your dashboard, you can see this branches section where you can go ahead and create a new branch. So here I'm going to give you the name. The convention is to go dev, the developer name as well. So I can have an isolated connection string for myself that I can always use in development. I'm going to select the parent branch to be main. It's going to copy everything current point in time. So at this point in time, so I'm going to create this new branch. And now this is going to give me a new connection string, which I can use inside my own local development area to set it in my env file to then work with my own data isolated from the production data. Each developer on the team can have their own branch, so they're not interfering with one another. You can also create branches for your preview deployments. There is a Vercel integration if you're deploying to Vercel that automatically creates a new Neon branch for each one of your preview deployments, which makes it very easy to work and test your real data before pushing to production. You can also reset any of these branches back to the parent anytime that you have merged in the new changes and the new migrations to your main production branch. You can then reset all of these branches to read from the parent again. So it just drops all the changes that you have created and resets or resyncs with the main branch. This is an absolutely great feature that allows you to work with your data the same way that you work with your code. And that's a wrap for this video, folks. We talked about Neon, a serverless Postgres database that allows you to deploy and create Postgres instances with a click of a button. You get a serverless endpoint that scales up and down automatically. It supports your traditional TCP Postgres drivers or the Neon serverless driver that allows you to query and connect to your database through HTTP or via HTTP instead of the TCP, which is suitable for serverless environments and specifically the Edge runtime that doesn't support TCP connections. We talked about branches in Neon, which makes it easy for you to work with your data the same way you would work with your code with different branches. If you have any questions, like always, hit me up down in the comments and I'll see you in the next one. Bye-bye.